Our objective today is to examine the standard, apply geometric methods to solve design problems. Students must be able to solve real-world problems that can be modeled using density, area, and volume concepts. To explore this standard, we will focus on a hands-on task for students. In this task, students are challenged to design and construct a container that holds exactly 1/2 gallon of water. The container is to be made from one piece of poster board and sealed with tape. Given the constraints of an exact volume and a limited amount of material, students select a three-dimensional figure and then get to work using their knowledge of volume formulas to solve for all necessary measurements. A sample rubric is presented here. This rubric shows that the process of solving is the most critical for the project. As the time comes to draw the net on poster board, students may find additional geometric relationships critical to their success. This project is a dynamic way to bring the standards for mathematical practice to life in the classroom. Students must reason quantitatively and persevere through computations that often challenge their understandings of how 3D figures are put together and how the measurements work together. Going back to the drawing board is a common part of this task. The strategic use of tools and attention to precision are the hallmark of the final two stages of this task.
I think that the half-gallon container project was probably one of the best applications that a student could see for the standard covering the constraints in the design, because not only did we give them a constraint that, hey, your figure needs to be able to hold half a gallon, they also had to be really precise with it. They had to understand that based on how they rounded and when they rounded in the problem, their figure could be way too big, it could be a little bit too small. So if they wanted to be as precise as possible, they really had to think the whole time about how they were rounding and things like that. And another thing I liked is they didn't just scream for us the entire time. They really did persevere through the problem. A lot of groups the last day had to completely start over from scratch. They had to chunk their poster board and just redo the whole thing, because when they got done, they realized, okay, we did this part wrong. And instead of griping, complaining, moaning, and groaning, they accepted the challenge and they stepped up and they got it done. And then to see them kind of pour the water in that final day and everybody's oohing and ahhing and cheering for somebody when they get really close, it was just really neat to see them apply and get excited about finally getting that project done.
Yes, but we're doing a triangle base. So the whole triangle has to equal that. It has to be the area. Area of triangle is 1/2.
Did we make an equilateral triangle or?
No. No, we didn't make it. But the area of a triangle is 1/2 this one's height.
So the base of the triangle.
I'm very confused. Does it mean this base? Okay. I'm doing a right triangle.
Okay, so we have to change the lateral.
You got a decimal, is that right?
No.
25.22. 25. Just do it. 23.2.
All right, so now why? So when you go to make your net, like you have there, and you have here, is that going to be the height? Y'all pay attention too. So if you've got your height here, but this is the part of your triangle, right? So then what are you going to do to find that?
Pythagorean theorem.
Okay, how are you going to use the Pythagorean theorem?
A leg and a leg. Wait.
Okay, so you just solved for your height, right?
Yeah,
So what was your height?
25.23.
Okay, so that's here. So then how long is this? Based on your measurements.
Isn't that like half of that's half, wait, no, that's half of the base, right?
Okay, so how long is that?
7.5.
Okay, so then how are you going to find this slant height?
You do this squared and this squared equals that. That's how hypotenuse, right?
So now where is that going to show up on your picture there? On your net?
What?
Where is that going to show up on your net?
Like one of these.
Is it here?
No, probably like No, I'm guessing
Hold
it's
on,
right
like,
here. It's right
hold
here.
on,
It's
wait.
this middle one.
So like, is it?
This one's the more slanted one.
It's gonna be like here.
So draw that. Okay, now there's, how is that special? Because it's hat, right? So when you look, and you go to look here, how are you going to draw that on your triangles? Like that you got it flattened out, right? Y'all have used this, and you got that. So then how are you going to know what those measurements are? So like, how long is this?
15.
Okay. So then you're going to solve for your slant height, right?
Yeah.
That's going to be where you get your measurements from. So is the height of this pyramid ever going to show in your net? No. Okay.
It shows me out when I'm on the top. It's not on the top. It's such a face. Like, it's okay. It's good enough. Okay, well that's a circle. Yay.
That's perfect. It's gonna win. It wins.
I'm stressed.
I give that one a 25 out of 5.
Wow, that's nice.
I know, right?
Oh, yeah, that's lucky.
Those warnings.
Yeah, that's
like,
perfect.
my goodness.
That's perfect. Yo,
Oh
my god.
Oh, perfect.
yo.
That was luck.
Yeah, that was nice.
All right, so last week I had the opportunity to do a couple of teacher observations on two of our math teachers, and I got to watch them doing the volume project. And from an assessment standpoint of the teachers, I found it to be quite a unique lesson in which they had their students all over the classroom, all over the hallways, working in collaborative teams, and 100% student engagement. The differentiation was neat to watch how the kids took that product of their choosing and worked it all the way out to completion. This particular lesson was level 3 and level 4 DOK. And so there were kids that struggled with the lesson, but the teachers were able to literally get down on their hands and knees on the floors with the kids and through tremendous questioning techniques lead the students to the proper answers that they needed to build the products. So I really like the targeted remediation that both teachers were able to give so many of the different kids as they worked through the process. But overall, the engagement of the students, the planning that the teachers put into this, just the overall product at the end was just a neat thing to observe and see come to fruition.